am Chandras Misra from ABES Engineering College. In this lecture, I am going to discuss types of graph. So we'll discuss null graph and trivial graphs, then directed versus undirected graph, regular graph, complete graph, connected versus disconnected graph, cyclic graph, and acyclic graph. We'll also see multigraph and weighted and leveled graph. So let's begin with the null graph. So a graph in which there is only vertex is known as null graph. So let's take an example. So here we have a graph. In this graph, we have only vertices like this. We have vertex. So we can label it as V1, V2, V3, and V4. So we can see here we have only vertex in this graph, but there is no edge between these vertices. So if we write it mathematically, we have V as a set of vertices like V1, V2, V3, and V4. But set of edges is 5. So as we already discussed in the previous lecture, like graph is set of vertex and edges. So if any graph having empty as the edge set, it is called null graph. Okay. So next we have another category is the disconnected and connected graph. So if a graph is having only one component, that is called connected graph. Or we can say if there exists at least one path between every vertex of the graph, it is also called as a connected graph. So let's take an example of the connected graph. So here we have vertices. Is if we label these vertices like A, B, C, D, and E. So if you want to move from A to D, there is a path A to B, B to C, C to D. We can reach. If we want to move from B to C, we have path. If we want to move from C to B, we have E to B, we have path. It means we have at least path from every vertex to other vertex. So this is called a connected graph. Connected graph. Let's take another example. So here we have a graph like this. Okay, so vertices are A, B, C, D, and here we have E and F, yeah, G. So you can see here we can reach any vertex from other vertex in this component. In this component, we can reach to B from A. We can move to D from A. We can move to C via B. So we have path for each vertex. But if we want to move G to vertex G from A, so we cannot reach to G via A because there is because this graph is disconnected. It is not connected. And here we have two components. So this is the first component C1 and this is the second component C2. So every set of connected vertices is known as component in a disconnected graph. So here A, B, C, D are connected, and another one is E, F, G, H, E, F, G are connected. So here we have two components in this disconnected graph. So this is the example of disconnected graph. Another category is the directed versus another one is directed versus undirected graph. So if there is a direction in the graph, like if we have a graph like this is the graph, and here if we have is like this, and vertices are A, B labeled as A, B, C, and D. So it means what? A is connected to B and B is connected to A. It means we can go from A to B and B to A because there is no direction given in this graph. Same as here A to D and D to A, D to C and C to D, C to B and B to C. So if there is no direction given in the S, this is called undirected graph. This is undirected graph. This is undirected graph. But if there is a direction like this, here we have vertex like this. So direction is given in the edge like A, B. It means what? We can move from A to B, but we cannot move from B to A. There's only one direction is given here. Here, B to C and C to B. But we cannot move from D to C. So here direction is given. So this is called directed graph. This is called directed graph. So it is very important whenever we are doing primitive operations or we are finding adjacent vertices or degree, all these things, we should cover, we should know whether the graph is directed or undirected. Now, the next one is a regular graph. So what is a regular graph? If a graph like here, we have a graph. So in this graph, vertices are A, B, and C. So we have to find out the degree of the vertex. So the in the previous lecture we have discussed the degree of vertex is what? The number of edges connected with that vertex. So here two edges are connected. So the degree of this vertex A is 2. The degree of vertex B is 2. Degree of vertex C is also 2. So we can see if the degree of all vertices are same, this is called a regular graph, and this is basically R2. This is a regular graph because the degree of all vertices are 2. So we can also denote as R2, that is a 2 regular graph like this. So it can be anything if we have vertex with degree of 1, that is 1 regular, 3 degree, that is 3 regular. So this type of graph is known as the regular graph. Now come to the point, what is the complete graph? If a graph is having connection between each pair of vertex, that is known as at least one connection between each pair of vertex, that is known as complete graph. So suppose here we have 4 vertices and name of these vertices are A, B, C, C, and D. So here we have edge between A and B. We have edge between B and C. We have edge between C and D. We have edge between A and D. Now, if we have edge between A to C also, and now D to B. Now you can see here we have direct edge between all pair of vertices. So A to B, yes. A to C, yes. A to D, we have this. Now come to B. B to A, yes. B to C, yes. B to D, yes. We have one edge. Now we take C. C to B, direct edge. C to A, direct edge. C to D, direct edge. And if we take D, so D to A, direct edge. D to B, direct edge. D to C, direct edge. So this is called complete graph. This is complete graph. Okay, that is also important. Now we have already discussed connected versus disconnected. Now, what is cyclic and acyclic graph? If a graph is having any cycle in this is called a cyclic graph. So we can take one example of the graph like this. We have a graph. So vertices are A, B, C, D, and D. Here we have a cycle A, B, C, A. So this is a cycle. So we can say this is a cyclic graph. And on the other hand, what is acyclic graph? If a graph is not having any cycle, that graph is known as acyclic graph. So we can consider any graph. This is not having any cycle like this. This is also a graph. Here we don't have any cycle. So this type of graph is known as acyclic graph. Now, what is multigraph? So, if we have a graph like this, and named as A, B, C, D. The vertices of the graph is A, B, C, and D. We have edges like this, like this. So we can see here there is only one edge between A to B. So if there is multiple edges between this A to B, we have another edge. So this is called multigraph. If we have more than one edge between two pair of vertex, that is known as multigraph. So this is a multigraph. Okay. And there is weighted and labeled graph. If there is a graph and there are weights assigned on the edges of the graph, this is called weighted graph. So we can take one example. This is the graph. Here A to B, A to B, then B to C, and here we have D. Okay. So if A to B, that is 1, B to C is 2, C to D is again 1, and A to D is 3. So what is the meaning of this? It means the cost of moving from A to B is 1. So weight is assigned to this edge. In the second one, here B to C is 2, C to D is 1, and A to D is 3. So this type of graph is known as weighted graph, and it is very important in real life problems. Like if we are going to find a minimum cost spanning tree, like this type of things, it is very important to know the weight of the edges. And what is labeled graph? If we have a graph in which edges are labeled with some name, like here we have like this. Vertices are named as A, B, C, D. And we have also labeled edges as E1, E2, E3, and E4. So this is called labeled graph. Okay. So thank you everyone for listening.